everyone. Good morning. How are you today? I hope you are doing well and ready to learn something new. Before we start, let me ask you something. How do you know if something is true or false? For example, is 2 plus 2 equals 4 is it true? Yeah, it is true. Now how about this? Is 7 is an even number? Is it true? Of course, no, that is false. So, in mathematics, we study this kind of reasoning in a topic called mathematical logic. And before we start, can you accept this? And before we start, let's take a quick look at our agenda. Today, we will learn about mathematical logic, starting from the definition, proposition, and open sentence. Then logical operation, implication, and biconditional, and finally converse, inverse, and contrapositive. Are you ready for learn today? Let's begin. And the first, let's start the definition of mathematical logic. Okay, mathematical logic is a branch of mathematics that studies statement and logical reasoning. It focuses on statements that have true value, which mean they can be true or false. In mathematical logic, we do not only look at the content of a statement, but also the structure of reasoning and the relationship between statements. Our mathematical logic helps us determine whether a statement is true or false, analyze relationship between statement, and draw valid conclusion. So remember guys, mathematical logic is not only about numbers, it is about thinking clearly and logically. Now, let's move the next concept, which is the proposition. Okay, a proposition is a sentence that has a defined true value. This means the statement can be either true or false, but not both at the same time. A sentence is considered a proposition if it has a clear meaning and its true value can be determined. And for example, it's a 2 plus 3 equals 5. This is true. And 9 is an even number. This is false. So, both of these are proposition because we can clearly decide whether they are true or false. And is a non for proposition is for example, have you studied? This is a question. And please do this exercise. This is a comment. There are not proposition because they don't not have a truth value. No, then we understand proposition. Let's continue to open sentence. Nah, we will learn about open sentence. An open sentence is a sentence that does not yet have a defined value. And this is because it contains variable, so we cannot say whether it's true or false yet. The true value can only be determined when the variable are replaced with specific value. For example, x plus 2 equal 5. Is this statement or true or false? We cannot decide yet because we do know that value of x. But if x equal 3, then 3 plus 2 equals 5, so the statement becomes true. And so remember guys, an open sentence becomes a proposition after we replace the variable with a specific value. Now, let's continue to logical operation. Okay, we will learn about logical operation. Logical operation are used to combine or modify statement. By using logical operation, we can form new statements, which are called compound statements. These operations are very important because they help us understand the relationship between statements and how their truth value is changed. So, what do you think happens if we combine two statements? We will get a new statement with a new true value, yeah? And now let's look at first logical operation. This is negation. Negation is a logical operation that refers the truth value of a statement. This means if a statement is true, its negation becomes false. And if a statement is false, its negation becomes true. The notation of negation is not P, written as negative P. So, in the original is true, what happens with the negation? It becomes false. Okay, for the example, P is it is raining today. Then not P means it is not raining today. Yeah, it is false. And we can also see this in the truth table. If P is true, then not P is false. And if P is false, then not P is true. Okay, let's move to continue to the next operation, which is conjunction. Conjunction is a logical operation that combines two statements using and. A conjunction, the only when both statements are true. If one them is false, then the whole statement becomes false. The notation of conjunction is a P and key, written as P and key. For example, P I study and Q I do my homework. So P and key means I study and I do my homework. Now, think about this. What if I study but I do not do my homework? Is the statement true or false? What do you think, guys? Yeah, if it's false, because both statements must be true. And we can also see this in the true table. It is only true when both and P and Q are true. In all other cases, it is false. Now, let's continue the next operation, which is disjunction. Disjunction is a logical operation that combines two statements using or. This conjunction, it's true if at least one of the statements is true. It only becomes false when both statements are false. The notation is of disjunction is P or key written as P or key. Look at the example. What do you think about if I study but I do not apply? If the statement true or false? Yeah, it is true because at least one statement is true. And what if I do not study and I do not apply? Now it becomes false because both are false. And look at the truth table. As long as at least one is true, the result is true. Now let's move to implication. Okay, an implication is a compound statement written as P implies Q. It reads as if P then Q. In in an implication, P is called the hypothesis and Q is called a conclusion. And for example is if it rains, then the road is wet. Now think about this. If it really rains but the road is not wet, is this correct? Okay, no, this is false. An implication is false only when P is true and Q is false. In all other cases, it is true. And look at the truth table. It is only false when P is true and Q is false, otherwise it is true. Okay, next is a biconditional. A biconditional is a statement written as P if and only if Q. This means both statements must have the same truth value. They are either both true or both false. For example, to get the example, a number is even if and only if it is divisible by 2. Now think about this. If P is true and Q is true, is this the statement true? What do you think, guys? Yeah, it's correct. It is true. Then the statement become false is the what if P is true but Q is false. And look at the true table. The biconditional is true only when both P and Q have the same value. Okay. And the next is the last topic is finally is the move the converse, inverse, and contrapositive. And given an implication P implies Q, we can form three related statements. What do you think? The first is converse. The converse is formed by switching the position of P and Q, so it becomes Q implies P. And the inverse. The second, the inverse. The inverse is formed by negating both statements. So it becomes not P implies not Q. And third, the contrapositive, it is formed by both negating and switching the position. So it becomes not Q implies not P. Okay, now which one has the same meaning as the original implication? What do you think about we learn? Yeah, yes, the contrapositive. An important property is an implication is logically equivalent to its contrapositive. And this means P implies Q has the same truth value as not Q implies not P. However, it is not always equivalent to its converse and inverse. And next, okay, okay, the conclusion. Finally, we have reached the end of our lesson. Today, we have learned about mathematical logic, including proposition, open sentence, logical operation, implication, biconditional, and also converse, inverse, and contrapositive. By understanding mathematical logic, we can think more clearly, analyze statement in and draw correct conclusion. Now, let me ask you, do you feel more confident about mathematical logic? I hope you do, okay? And thank you for attention. Keep practicing and stay curious. See you in the next lesson. Goodbye, guys.